Hi there, and welcome to Raelene Maths. In this video, we will take a look at the factored form for a quadratic equation and use that form to graph a parabola. The factored form is y equals a times x minus r1 times x minus r2, where the x-intercepts are located at r1, 0 or r2, 0. In this example number 3, we are given the quadratic equation in factored form, and so to get the x-intercepts, we will intersect with the x-axis, whose equation is y equal to 0. Solving this system of simultaneous equations, we eliminate the y by substituting 0 for y in the first equation. When we do this, we get a factored form that says if the product of two things is equal to 0, then one or the other factor must be equal to 0. This property is called the zero product property, and as a result we have either the first factor, x plus 1 must be 0, or the second factor, x minus 5 must be 0. There's a third possibility where the two factors are both equal to 0, but the factors are different. This enables us to solve two linear equations as opposed to one quadratic equation. So we get that our two x-intercepts are located at -1, 0 and 5, 0. This explains why from the factored form we have a negative r1 in the brackets but a positive r1 for the root, and similarly for the negative r2 turning to positive r2. So we go from the factored form to plotting the x-intercepts at -1 or 5 along the x-axis. The next thing we are asked to do is to expand the brackets and identify the y-intercept. So expanding the brackets, we multiply and take first times first, which gives x squared. Multiplying the outsides is -5x, multiplying the insides is positive x, and multiplying the lasts gives us -5. So we can write the quadratic from factored form in standard form, or expanded form, as y equals x squared minus 4x minus 5. To get the y-intercept, we do another intersection with the parabola and the y-axis, whose equation is x equal to 0. Now we eliminate x by replacing x in the green equation with 0. This gives us that y is equal to -5, and so we can see the y-intercept is located at 0, -5. The next thing we want to do is take a look at the axis of symmetry, which is a vertical line that cuts the parabola into two equal halves. So if we sketch a vertical line, we can move that vertical line to what seems reasonable for the points and information we know about the parabola so far. The axis of symmetry has to be midway between those two blue x-intercepts. And so we could actually count and get that it looks to be right around here. But to find out that number exactly, we are going to find the average of the two x-intercepts, the mean. So we add the two roots, r1 and r2, or the two x-intercepts together. We divide by 2. So we add -1 to 5, and then we divide by 2. This gives us 4 divided by 2, which is equal to 2. And that seems reasonable. X equal to 2 is that vertical line. And so we can just move it over a little bit, shuffle the line to the left, and we have the axis of symmetry. The last thing we want to do is come up with a turning point, which is a special point at the intersection of the parabola and the axis of symmetry. Because the turning point lies on the axis of symmetry, we know its x-coordinate, and now we just need to find the y-coordinate. The turning point has to lie lower than the y-intercept in this case to give the concave up shape of the parabola. All we need to do is find out exactly what that height of the turning point is. So we solve for y when x is equal to 2. This is yet again another intersection. If I take the factored form, y equals x plus 1 times x minus 5, and intersect it with the vertical line whose equation is x equal to 2, then I can eliminate 2 by substituting 2 in for x. Doing this gives me that y is equal to 2 plus 1 multiplied by 2 minus 5. This is 3 times -3 and gives the y-coordinate of the turning point at -9. So now we see that the turning point is at 2, -9, and we can finish sketching the parabola. But first, I would like to confirm that we could use any quadratic form instead of just the factored form. So if we substitute x equal to 2 into the expanded or standard form, we end up getting y equals 2 squared minus 4x, which is 2, and then take away 5. And so working this out gives us y equals 4 minus 8 minus 5, which is negative 4 minus 5, and therefore y is also equal to negative 9. So you can use any form that you want to substitute an x-coordinate and work at the y-coordinate. I personally prefer the factored form, the way that we did it in red first, but either way gives you the y-coordinate of the turning point located at negative 9. So now we have the turning point. We'll just place that point a bit more accurately at 2, negative 9. And we can use the symmetry of the parabola to come up with the mirror image of the green point, which is 2 spaces on the other side of the axis of symmetry. We also have the same size as the parent function, the y equals x squared. So starting at the turning point, we go right or left 1, up 1, right or left 2, up 4, right or left 3, up 9. And that's enough information to sketch this parabola fairly accurately. So there you have this parabola. Let's take a look at another example. In this example, let's first get the x-intercepts by finding the intersection points between the given equation, the quadratic equation, whose graph is a parabola, and the x-axis. Now the equation of the x-axis is y equal to 0. So we're going to solve this system of simultaneous equations by eliminating y and substituting y equal to 0 in the first equation. The resulting quadratic equation is in terms of only one variable, and the first thing I'd like to do is get rid of that negative 1/2 factor by multiplying both sides of the equation by negative 2. So multiply by 0 gives us 0, and negative 2 times negative 1/2 is positive 1, and then we still have times x plus 4 times x minus 4. That 1 isn't necessary, so I'm just going to erase it. Then, by the zero product property, if 2 or more factors multiply together to give 0, this says that either the first factor equals 0, or the second factor equals 0, or potentially they both equal to 0. These factors are different though, so we have only one or the other factor equals 0. This gives us x equals negative 4 or x equals positive 4. And there is a sign change from the factor to the root. That comes from having solved those two linear equations. Now that we have our two x-intercepts, we can find the midpoint of those two x-intercepts to come up with the axis of symmetry. Now recall the axis of symmetry is a vertical line that cuts the parabola into two equal halves. So let's imagine drawing a vertical line and then moving it so that it's at the midpoint of those two x-intercepts. It has to be somewhere in the middle, right around here. It looks like the y-axis is the axis of symmetry. And so to do a confirmation, we are going to find the average of the two x-intercepts by adding together and dividing by 2. This is the mean kind of average. So we take negative 4, add it to positive 4, and divide by 2, which gives us 0 divided by 2, which is equal to 0. And so x equal to 0 is indeed the equation for the vertical line whose label and name is the y-axis. So now that we've got the axis of symmetry, we know that the turning point has to lie on that vertical line. So we can find the turning point as another intersection, this time of the given graph, the parabola, whose equation is given in factored form, as well as the vertical line, which is the axis of symmetry. And the equation of the axis of symmetry is x equal to 0. So we can solve this system of simultaneous equations by substituting 0 for x and solving for y. Doing this gives us y equals negative 1/2 multiplied by 0 plus 4 times 0 minus 4. This gives us y equals negative 1/2, and then 4 times negative 4 is negative 16. And so we can multiply negative 1/2 times negative 16 to give us positive 8. So the turning point is located at 0, 8 on the axis of symmetry. The next thing we will do is plot the y-intercept, which is another intersection point between the given parabola, whose equation is still stated in factored form, and we will intersect that parabola with the y-axis. The equation of the y-axis is x equal to 0. So substituting x equal to 0 into the first equation will solve the system of simultaneous equations. When we do this, we end up getting at x equals 0, the y-coordinate will be 8. We've already done this for the turning point form because we found that the turning point and the y-intercept are the same points. So we have the y-intercept is located at 0, 8, but let's confirm by expanding the factored form to standard form for the quadratic. When we do that, we get y is equal to -1/2 multiplied by x times x, which is x squared, x times -4, which is -4x, 4 times x, which is positive 4x, and positive 4 times -4, which is -16. We can collect like terms inside the brackets before distributing the -1/2. Multiplying through gives us -1/2 x squared plus 8, and here we see that the plus 8 is the constant from the standard form, which is the same as the y-intercept. To plot a few more points on the parabola, let's consider the value of a. For the parent parabola, a equals 1 and is concave up. A concave down parabola of the same size has a value of a equal to -1. We would go right or left 1, down 1, right or left 2, down 4, right or left 3, down 3 squared, which is 9. But our a value is equal to -1/2, and this 1/2 makes our parabola shorter than the parent graph. So we would go back to the turning point, and instead of going up, we know we're going down because a is negative. Then we would go right or left 1, and normally we would go down 1 space, but this time we're only going down half as much. We go right or left 2, normally down 4 spaces, but this time only half as much. We go down 2 spaces. If we go right or left from the turning point 3 spaces, we would normally go down 9, but now we are only going down 4.5, 4.5 spaces. And we do that on both sides of the parabola. If we go right or left 4 spaces, 4 squared is 16, and half of that is 8. That lands on the x-intercepts, and so we can see that we have plotted the parabola accurately. In upcoming videos in the same series, we will look at how to use different quadratic equation forms to graph the parabolas and to get all of the information such as x-intercepts, y-intercept, axis of symmetry, and turning point. Stay tuned for more on graphing parabolas. Thanks for checking out Raelene Maths.